Woohoo! Here we go. Chapter 11. Oh my goodness, we're practically through the whole book, through the whole year. Can hardly stand it. So, the job now is to get you ready and rocking for Algebra 1. So, here we go. I'm splitting section 1 of chapter 11 up into a couple of pieces because there's a lot in here and I want to make sure we master each part before we dive into some big old equation solving. So the top of your notes should say chapter 11 section 1a because section 1a is more on simplifying expressions. And we're going to talk a little bit about some properties and we'll continue our property work tomorrow. Okay? Learning target for today is you are going to simplify algebraic expressions by combining like terms. Awesome, awesome. So here we go. Terms. So we should make sure we know exactly what we're talking about here. And what terms are is, and I'm specifically talking in math and in an algebraic expression, or it could be a numerical expression too. These are the pieces or the items that are separated by an addition or a subtraction sign. So I write it here this way, separated by plus or minus signs. Okay, so it's in an expression. And I didn't specify what kind of expression because it could be something as simple as a numeric expression like 13 plus 7. Okay, so technically right there, what you're seeing here, these two, the number 13 and the number 7, there are two items there. In other words, two terms. They're separated by an addition symbol. Algebraically, I could have something like this. 7x minus 5. There's another example. The 7x is a term. The 5, or subtracting 5 is a term. You see how they're separated by, in this case, a subtraction sign. We could also have something like this. 3y minus 4x plus 10b minus 4. And I've got this. You have 4 terms in this particular expression. Okay, so it's just the little items that are separated with a plus or a minus. What we're really focusing on today is when you have a big long expression, can you simplify it? Can we condense it? Can we put things together to make this long thing look a little more neat and tidy and compact? So your eyeballs are going to get trained to look for like terms. So let's say that we have an expression like this on the top. And I use this big, huge one. 7x, there's a term. Here's a plus sign. 5, then a subtraction sign, then a 3y plus 2x. So right now I have 4 terms. Out of these 4 terms, your job is going to be now to look for things that are alike, that are similar, that are same. Okay, and particularly what we define them as is that they have the same variable and it's raised to the same power. Okay, so here's 7x. Okay, I look at the next term, which is 5. Do they have, since this is a variable, a letter, does this have a variable? Not alike. Then I look at this 3y. Oh, that has a variable, but it's y. This doesn't have a variable. Nope. This has a variable, but it's x. X and y different. No luck so far. Come down here and you say 2x. Woohoo! 2x, a 7x. Those two are alike, we say. Okay? They're like terms. The kicker, there's one other stipulation, and we'll run into it once in a while, specifically when you get higher up in algebra, is not only do they have to have the same variable, but if they have the same variable, it has to be raised to the same power. Okay, we won't deal with a lot of that, but I just want you to know if you see that, they both have, say, x's, then we need to make sure that you can determine if they're like terms or not. I just want to be able to extend my screen here. So let me make sure I have that turned on and make sure this is what we're going to do. So combine like terms is our job for today. And we have to make sure that you take or keep the sign, meaning the plus or the minus sign, that's right in front of the term. It's stuck with it. So take a look here. This plus 5, you're always going to keep the plus sign with the 5. It's stuck with it. This minus 3y, subtracting 3y, I want you to stick that minus sign with 3y always. Start thinking of it as negative 3y. The plus 2x, think of it as like a positive 2x. Okay, that'll come in handy when we start combining. So let's do it. Write this one down. Ton of examples today. We're just going to blast through, and the more you do it, becomes automatic. Here we go. 5x plus 9x. Okay, I have two terms here, and I'm always saying, can I make this a lot easier to look at, for goodness sakes, by combining these guys? You certainly may, because this is x, they are alike, and all you have to do is add the numbers in front. The numbers in front, you're going to hear me call them this often. Coefficient. Coefficient means that's the number that's multiplying your variable. Okay, so all you have to do is add 5 and 9, 14 x's. Okay, it's kind of like saying 5 teddy bears and 9 more teddy bears make 14 teddy bears. Or 5 chocolate bars, yes, and 9 chocolate bars make 14 chocolate bars. There you go. All right, so if I gave you one that looked like this, 5x plus 9x to the second power, you might be tempted to just say, oh, well, what's going on with that variable? They're both x's, but this is x to the second power. Our definition back here said the variable had to be raised to the same power, so guess what? We can't combine these. Illegal move. In fact, if I asked you to simplify this, it would be completely appropriate for you to say, can't simplify. They are not like terms. There's no combining that you can do. You just leave it as is, and that's what you get, okay? All right, so now let's start looking at some of these. Here's one that has 4 terms, 4n plus 6n minus 3y plus 7y. Okie dokie, artichoke. Here's the deal. 4n and 6n are like terms. What I like to do is kind of either draw boxes or circles or somehow note that I'm going to combine these two together. And notice when I went and circled this one, I included the sign right in front. I want you to think of this as positive 4 and a positive 6. That makes 10 n's. Yes. When you get over here, here's where I want you to be careful. This says minus 3y. I want you to think of that as negative 3. Negative 3y. And a positive 7y, and combine those two together because they're like terms. They both have y's. How many y's do you have? You have specifically 4 of them. Is that 4 positive or negative? It's positive. Put a plus sign. N's and y's are not alike, so we can't combine anything any further. We leave it like this, but we've simplified it from this 4-term expression into a 2-term expression. Looks a lot neater, easier to work with, easier to evaluate. Okay. All right, let's keep going. Look at this one. 4a plus 7 plus 2b plus 8b. How lovely. Everything's positive here. So what you do is you get this written down and then you put on your algebra eyes. Algebra eyes. Yes. When you walked in my classroom the first day of school, you didn't even know it, but like poof, I implanted algebra eyelids or glasses, goggles, something like that. They're invisible. You can't even feel them, but you start to see things mathematically. Here you go. When you see 4a, you're saying, all right, I'm looking down the rest of this expression for any more a terms. Do you see any? Nope. So guess what? 4a just comes on down, has no one to play with, but, you know, she's confident in her beauty. She doesn't need anybody else. Here comes the 7. All right, it's a positive 7. Now, 7 doesn't have a variable. It's just a number. We sometimes in math also call that a constant because it's 7. It doesn't change, it's just there. And so you look down the expression, see if there are any other constants in there. No other numbers, so guess what? 7, you're coming down as well. But then I have a plus 2b and a plus 8b. Those guys are alike, and you can combine them into 10b's. But that's all you can do, okay? But at least we simplified it a little bit. There you go. All right, next, let's look at this one. 5k plus 7n minus 3n plus k. All right, here's another level of, let's watch for this. I start with my 5k, and I'm looking downstream. Oh, take the sign in front, okay? It's kind of like that country song a few years ago by Sugarland, where they say, you and me, baby, we're stuck like glue. So I want you to think of that sign right in front. It's stuck like glue to K. There's something other, some other little interesting observation about this term here. And that is, I don't see a coefficient right now. It just says plus K. K. There's really a number there. Do you know what it is? It's 1. The reason why we don't always write it is because 1 times something is just that thing. 1 is called the identity in multiplication. It just spits back exactly what you've got. So sometimes we don't write it, but I like to put it in there because now what I need to do is take this 5k and I'm going to bring this plus 1k further upstream. I'm rearranging the order, which is legal because in addition, there's this little property called the commutative property that says I can switch the order. Switch, if I could spell, that'd be handy. I can switch the order when I add, and I'll still get the same answer. So it's a legal move to do. All right, so I can take these two and combine these two together, and that will give me 6k's. All right, 6k. Where can I squeeze this in? 6k. Sorry. Blech. All right, now maybe I'll switch color to make it a little easier now. Now I have a 7n. It's a plus or a positive 7n and a minus 3n. Keep the signs together because you and me, baby, we're stuck like glue. Woo-oo, woo-oo. All right, here we go. My n terms can be combined into 4n's. Is that 4n positive 4 or is it negative 4? Positive 3 or positive 7, negative 3 gives me positive. So your final answer, when you simplify this, will look like this. I have a 6k, I have a positive 4n. That's as far as I can go. Done. Nice. Okay, watch your signs. Keep the signs stuck with that term, just like glue. All right, last, look at this one. 4 plus 7f minus 7g. And your directions are simplify this expression. Well, here's 4. It's a beautiful constant. I'm looking downstream. Bzzz. Nope, I don't see anything else. So 4 is just going to hang out here. A 7f, no f terms, so 7f has to come on down. Then I have this minus 7g. Guess what? 3 terms, none of them had any like term further on in the expression, so you can't simplify it. You can either rewrite it or simply write, I can't simplify it. Last but not least, let's look at this one. 8m minus m plus 3 minus 2m plus 5. 1, 2, 3, 4. 5 terms in this expression. Here we go. I see an M, so I'm going to grab all of my M terms first. 3 of them. 8M. Oh, no coefficient here. Ding, 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 ding. That's really a 1. So I have a minus 1M. And then, you and me, baby, we're stuck like glue. Minus 2M. All right, so there's all of my M terms that I can combine into one thing. 8 minus 1 and minus 2 more. So minus 2, 5. So I have 5 m's left out of all of that. Okay, so I took care of this. Now, I have constants left, and in particular, I have a positive 3 and a positive 5, plus 3 and a plus 5. Now I can combine these guys together. Notice how I'm switching the order all around here? Totally legal to do because the commutative property says all of this is really adding. I know you see subtraction signs here, but when I'm thinking of it as keeping the sign with this, it's like I'm saying this. A minus 1m is like a negative 1m, and we're really adding negative 1m. Okay? When you go way back to that thought about subtraction is the same as adding the opposite, everything's addition in disguise. Boom. There you go. All right. So all of that turned into this lovely 5m plus 8. What a lovely little variable expression that came from that big ugly thing. Awesome. All right. Your challenge for today, I have a worksheet for you, combining like terms. I strongly suggest as you start doing this, use your idea, especially when you have more than one thing, like especially number 2 here. Here's 12r. There's no other r terms, so I'm going to take 12r and bring it on down. But now you have a negative 8 and then a negative 12. Okay, a negative 8 and a negative 12. If you want to think of this as subtraction, fine and dandy. If it's easier for you to think of this as a negative 8 plus negative 12, fine and dandy. Do so. But these two give you negative 20. And you can write it like this. Beautiful. If you want to write it like this, 12r plus negative 20, and sometimes we'll put parentheses around that so I don't have plus minus right in a row. You can write it like this too. These mean the exact same thing. Okay, but combine your like terms, get them as simplified as possible, and again, watch your positive and negative signs. All right, worksheet. There's a backside. Don't be slacking. All right, good luck. And as always, may the force